All right, today we're going to pull back the curtain on something we use every single second of every day, but maybe don't think about too much: computer networks. We're going to go from the tiny connection between your phone and your headphones all the way up to the massive system that connects the entire planet. So let's dive in. It all starts with something super simple. You pop in your wireless earbuds and boom, they're just connected to your phone. Like magic. How does that actually happen? Well, that little bit of magic, that's a network in action. And it's the perfect place for us to start. Okay, so what is a computer network, really? When you strip it all down, it's just a bunch of connected devices, could be computers, phones, printers, you name it, that are all linked up so they can swap data and share things. It's all about two things: talking and sharing. That's it. And to really wrap our heads around this, we're going to start small. Like, really small. We're going to start with the network that is all about you. So that magic with your headphones, that's happening on what's called a personal area network, or a PAN. The best way to think about it is like your own personal tech bubble. It connects the stuff that's just a few feet away from you. Your smartwatch talking to your phone, your wireless mouse talking to your laptop. It's the smallest kind of network there is. Okay, so from that little bubble, things start to get bigger, a lot bigger. These networks start to build on top of each other, connecting not just your stuff, but your home, your city, and yeah, eventually the entire world. The very next step up is the LAN, the local area network. Now, this is probably the one you're most familiar with, even if you don't use the name. This is your home Wi-Fi network, or the network at your office. It's the reason every computer can use the same printer, or why you can fling a movie from your laptop straight to your smart TV. Now, what happens when you start linking a bunch of those LANs together, say across a whole town or a big college campus? Well, then you get a MAN, a metropolitan area network. This is what might connect all the different buildings of a university or all the branch offices of a company across a city. And that brings us to the final, biggest step. When you start connecting networks over huge distances, we're talking across countries, across oceans, you get a WAN, a wide area network. And what's the biggest, most mind-bogglingly huge WAN on the planet? Come on, you know this one. It's the internet. It's not one network. It's a massive network of networks. Okay, hold on. We've got these networks of all different sizes, connecting literally billions of devices. And that raises a pretty huge question, right? How do they all manage to talk to each other? I mean, really think about it for a sec. You've got an iPhone from Apple, a laptop running Windows, maybe a smart fridge from Samsung. How in the world do all these gadgets from totally different companies that are competing with each other all manage to communicate so perfectly? There has to be some kind of shared rulebook. And that's exactly what a protocol is. A protocol is just an agreed-upon set of rules for how to communicate. It's just like a language, right? For two people to understand each other, they need shared grammar and shared vocabulary. Well, for two devices to talk, they need a shared protocol. So what's actually in this rulebook? Well, it boils down to three main things. First, there's syntax. That's the structure, the grammar of the data. Then you have semantics. That's the meaning. What is this data actually trying to say? And finally, timing. This is all about when to send data and how fast, so you don't just overwhelm the device on the other end. All right, so having a bunch of rules is awesome, but you need a way to organize them, right? You can't just have them all thrown in a pile. You need a blueprint, a structured plan for how a message gets all the way from your app down through the wires and to its destination. And that's where the idea of a layered model comes in. Honestly, the best way to picture this is like a big office building. Every single floor has one very specific job to do. The top floor is your app, and the bottom floor is the physical cable. And here's the trick. Each floor only has to talk to the floor directly above it and directly below it. It makes a super complex process manageable. Now, in the networking world, there are two famous models for this. There's the OSI model, which is this perfect 7-layer theoretical blueprint. It's how networking should work in a perfect world. But the one we actually use, the one that powers the internet you're using right now, is the TCP/IP model. It's more practical, just 4 layers, and it basically won the race because it grew up with the internet. So let's follow a single message on its trip. Your app, say your email, writes a message. As that message goes down through the floors of our building, each floor wraps it in a new layer of info. It's like putting a letter in an envelope, then putting that envelope in a box, then putting a shipping label on the box. The whole package travels across the network, and on the other end, the process just happens in reverse. Each layer unwraps it until the original message gets to the right app. Pretty clever, huh? Okay, so we've talked about how big these networks can get, and we've talked about the rules they use to communicate. There's just one last piece of the puzzle. What do these networks actually look like? What's their physical shape? That physical layout, the actual shape of the network, is called its physical topology. It's basically the map, right? A diagram of how all the different devices, we call them nodes, are physically hooked up to each other. So let's quickly run through the most common shapes. First up, the star. This is probably your home Wi-Fi network. Everything connects to that one central router. It's pretty reliable, but if that router goes down, so does everything else. Then you've got the bus topology, where everyone shares one main cable. Super simple to set up, but man, if something breaks, finding it is a nightmare. In a ring, devices are connected in a big circle, which is orderly, but if one link in that circle breaks, the whole thing can go down. And finally, the big one, mesh. Here, every single device connects to every other device. It's incredibly robust, but you can probably guess it's crazy expensive to set up. All right, so let's tie this all together. What are the big takeaways here? First, networks are all about connecting stuff so we can share data. Simple as that. Second, they come in all sizes, from your personal bubble, the PAN, all the way up to the global WAN, the internet. Third, protocols are the universal language that lets totally different gadgets understand each other. Fourth, those layered models, like TCP/IP, are the blueprint that keeps all that communication organized. And finally, the topology is the actual map of the network, and the shape you choose has a huge impact on cost and reliability. And that brings us to a final thought. Look around. We are barreling towards a future where literally everything is connected to the internet. Your car, your fridge, your coffee maker. So I'll leave you with this to chew on. As every single device gets a connection, what's the one thing, the one object you hope never joins the network? Thanks for tuning in.